Okay, so yesterday we were talking about what h and k as numbers will do to a graph. Now remember, when we're graphing quadratic, if we're graphing f at x equals x squared, which is our original, the vertex is at the origin, 0 and 0. We go over 1, up 1. We square those numbers. We go over 2, up 4. The reason we do this is because when we plug in 2, 2 squared is 4. Same with negative 2 squared is also 4. And finally, 3 squared is 9. So we do 9 on both sides. So, we connect the dots. We have our original parabola. If you remember, if h is a positive number, so something like positive 3, I would move the parabola 3 to the left. Same parabola, shifts to the left 3 units. If h is negative 4, I would use the same parabola, but I would shift it right 4 units. Okay? So h deals with moving the parabola left and right. K, if k was positive 2, that means I would shift that same parabola up 2. So we have the same shape object. It's gone up 2 in this direction. And let's say k was negative 5. I would have the exact same parabola again. Vertex is now at negative 5. Sorry, I know that's not quite the same shape, but it's been shifted down 5 units. Negative 5. So k is up and down. H is left and right. Left and right. Okay, so we've covered h and k. That's when we're not manipulating the parabola at all. It's still the same shape. We just move it left, right, up, and down. A has a different effect on the parabola. Depending on what A is, we'll get a thinner parabola or a wider one. Or if A is negative, we're going to end up with a parabola that's downwards. Okay, so I'm going to actually put in values for A, and I'm going to give you some restrictions. So, with A, first of all, if A is greater than 1, so examples of numbers greater than 1 are 5, 10, 20 billion. If A is greater than 1, then the parabola is stretched. Oops, hold on, spelled that wrong. It's stretched and it is made thinner. Okay? So what I mean by that is if we have, say, the black version is our original. I actually didn't hear him. The parabola will look like this. It'll be thinner than our original. So again, I'll show you what that is on the graph. That's our original. If A is a number greater than 1, then it will look something like this. It may be even thinner or maybe a little wider, but it'll definitely be thinner than our original one. Okay, the next change could be if A is between 1 and 0. So in other words, if we have fractions or decimals, so if I have 1/4 or I have 0.37, these are all numbers that are between 1 and 0. What's going to happen is the parabola then becomes compressed. Or you call it, many of you would say it's fatter. Okay? So, again, let's say the black one is our original. Our red one would be an example of what the new parabola looks like. If you notice, it's wider. It's been compressed. So again, think of it like you're compressing an elastic band. It gets wider. 0.5, something like that.
We have to sketch a graph.
So in other words, again, we have our original one. A compressed graph would look something like this. Okay? Our parabola would now be wider. We're going to go into that. Thank you. If A is negative, it is flipped, the parabola. So we turn it the other way. So again, let's say the black one is our original. A flipped parabola will look like this. Okay?
Three people.
So, If a is negative, that means we have a parabola that's heading that way. It's heading downwards. So, always draw the skeleton model or the original. So we have our a, x minus h squared plus k. I just didn't color code it this time. Does anyone know what our a value is when we're referring to this equation? 3, that's right. Because a is always in front of whatever the x is, it would be the coefficient. So our a in this matter is 3. Okay? What about in this one here? A is 1/2. Good. So let's draw our original one again. The vertex is at 0, 1 and 1, 2 and 4, and 3 and 9. We put our original one up. Okay. So remember what I was telling you before? We go over 1 and then we square that number to figure out how much we go up. Now to figure out how to draw something where a is a different number, we're going to have to square it and then multiply by a. So I'm going to give you a little equation. Okay? And in fact, the equation, well, your equation will be whatever your x value is, so we call it our x, you're going to square it, and then you're going to multiply it by whatever a is. That will be your y. And if you guys look, that's the exact same equation we have written up here, except we're using f at x is equal to. So we plug in our values for x, we square them, and then multiply by whatever a is. So let's say we're at 0. What is 0 squared?
0.
Yep, and 0 times 3? So that means our first point is going to be right here at the 0. Okay? Now let's say x is the positive 1. What is positive 1 squared? Okay, and then 1 times 3. So when x is 1, y is what? 3. What about at negative 1? Negative 1 squared is positive 1.
Come on, Troy.
And positive 1 times 3. So if you guys notice, it looks like it's going to become a mirror image. So what about if x is the number 2? 2 squared is, and 4 times 3 is 12. So if you notice, this is not even on the graph. It would probably be somewhere up here. So this parabola is thinner or stretched in that matter. So this is referring to this graph here. 3x squared, we have a thinner parabola. It's been stretched. Next one we're going to deal with is this equation here. Our a value is 1/2. So again, let's start at 0. If 0 squared is
0
times 1/2? 0. So let's do this one in, actually we'll do it in red again. It's okay. No, that one's too thick. Okay, so we're at 0. What about if x is 1? What is 1 squared?
1
Times 1/2.
1.
It's just 1/2. So instead of going up to the point 1, I only go halfway there. And I do the same on the other side. Okay? What about the number 2? 2 squared? 4. 4 times 1/2?
Is it 4 times 0.5?
It's 2. 4 times 0.5 is 2. So at the number 2, our y value is now 2.
2 and 2? Oh,
Okay? What about the number 3? 3 squared is?
9.
9? And what's 9 times 1/2? Anyone know?
6.
5.
4.5.
4.5. 4.5 is half of 9. No, this is our new compressed one. Let's do 4 also. What is 4 squared? Times 1/2? 8. So I want you guys to look at this now. Alright.
So what's the purpose?
Recording.
What's the purpose?
Recording. So our new parabola has been compressed. if you notice, this one is wider. Think of it like there's an anvil on top and it's pushed it down. Okay? Just like if it's stretched, think of someone's grabbed the two ends and pulled it upwards. So this is now wider than our original one. And finally, I do have to do another one. Let's work with f at x is equal to negative 2x squared. Okay? So because it's already negative, we know that's our a value. A is going to be negative 2. This is going to be a parabola facing downwards. So we're going to do the math here, and I'll do a little table for you so you guys can see what I'm talking about. So if x is 0, we plug 0 into our new equation, right? What is 0 squared? 0. Times negative 2. So it looks like 0 and 0. Again, we're going to have a vertex that's at the exact same spot. Okay? This time, let's plug in x at positive 1. Okay, now I'm just arbitrarily grabbing numbers, guys. If you notice, there's not going to be any order to this. Okay? So if x is positive 1, I put positive 1 into this equation. 1 squared. And what is 1 times negative 2? Negative 2. So now my x point, my next coordinate, is x is 1, y is negative 2. So it's facing downwards and it's been stretched. Okay? Now we know that it's going to be the same on the other side, but I just want to prove it. Let's go when x is negative 1. Oops, I won't do that in black. When x is negative 1, let's plug it in. What is negative 1 squared? Positive 1. Negative times a negative is a positive. Positive 1 times negative 2. So again, I have negative 2. So if you guys notice, my next point has been stretched and it's facing downwards. Let's do the same with x at 2. So x at 2, what is 2 squared? 4. And what is 4 times negative 2? Good. So our next coordinate is 2 and negative 8. And we know it's going to be the same on the other side. So if you guys notice, this parabola, when a is negative, is going the other way. And because a had a value, remember it was the value of 2, it's actually stretched compared to our other one. So it's facing downwards and it's been stretched.